Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about some of the applications of partial differentiation. I hope you have already watched all those videos which belong to partial differentiation on my channel. If not, then I can provide you the link in the description. You can check them out. Now, what's there is we are about to study errors and approximations using partial differentiation. So let's get started with the help of an example. So here the question is given to you that the time period of a simple pendulum, the formula for time period is this: 2 pi square root of L by G, and you need to find out the maximum error in the time period due to the possible error up to 1% in length and 2.5% in gravity. So basically, you know, what do you mean by errors and approximations? Let's say you have a function, okay, in terms of x and y. It is a continuous function. Now, if you have any changes, let's say by mistake or by error, you get these figures, you increase these figures by del x, you increase these figures by del y. What do you mean by del x or del y? So let's say initially you have 10 rupees, now you've got 20, so the change is 10, which is the change here, del x and del y, change in the values of x and y. Now your new value of function which will be having the changes will be x plus del x, y plus del y, okay? And if you want to find out, this will be your new f. You can say this was your f1, this is your f2. Now if you have to find out the change del f, that will be f2 minus f1, that means f x plus del x, y plus del y, minus f xy, correct? So this is how you can calculate the approximations using partial differentiation. Let's see how. Here what is given to you? 1% in length. So the error which is given to you, that means change in length over the original length into 100, then only you will get the values in percentage, right? This is 1. And the change, how you find out the values in percentage? Change in numerator, original value in denominator into 100. That is given to you as 2.5%, right? Now, what's the role of partial differentiation? See, this is your function t, right? Now, because it is in, there is an operation of division in between L and G. So what you need to do to solve this, take logarithmic both sides. So log 2 pi root L by G, right? When you expand this, this will become log t. You know very well that in multiplication log adds up. So log 2 pi plus log root L, and this is in denominator, so log root G, correct? Now what happens? What you can do here now, you can differentiate it, partially differentiate it, okay? So what it will give you, this will be, if you have any function, the value of log x, let's say you have log x, what's the differentiation of log x? 1 by x, if you do with respect to x only. But here it is an implicit functions having different variables. So what you will do, differentiation of log t will be 1 by t, but you will mark delta t, or you can say partial differentiation of t. Here it is constant, so if you go with log 2 pi, so it will be, differentiation will be 0. Then here if you see, root L means L raised to power 1 by 2. So when you solve log, power comes out as coefficient, right? And now you have L, so that will be delta. For log L, what you have got? 1 by L, and delta L will be your partial differentiation. Same here, 1 by 2, 1 by G, delta G, correct? Now you can substitute all the values, because you have values in percentage, that means you need to multiply whole equation by 100. Okay, with 100 you have multiplied it. Now what you have got is, you have to find out the percentage error in t, so this is your value which you need to find out. You can take half common from here. Now delta L by L into 100 is what? 1. Now this is in minus, we know. But if you remember here, what we do? We have errors added on. Correct? We can't say that, let's say, initially we had some value 2 and now we made some changes and it is the value 2.5. So this 0.5 is the error which is in plus, correct? So we can have two possibilities. Error can be added and minus sign is from here. What is the value of this into 100? This is given to us 2.5. So there can be two possible values if we have errors, half into 1, correct? So 1 plus 2.5 and half 1 minus 2.5, correct? So if you will do half 1 plus 1.5, let me erase this bit, just bear with me. So how you will solve this? Here you have 2.5 plus 1 is what? 3.5. That means it will become 1.75, and here you've got minus 0.75. So the maximum error out of these two is 1.75, which will be your answer. Okay, so this is how you can find out the errors using partial differentiation. Let's see another example. Here, another application of partial differentiation. Question is saying a balloon is in the form of right circular cylinder. Okay, so it is in the form of cylinder. What you have got is its radius is 1.5 meter, height is 4 meter. So this is 4 and this bit is 1.5. It is surmounted by hemispherical ends. It is not mentioned one end or at the two ends, so we are putting at both the ends. So now the radius is increased by, when we add these hemispherical ends, there is an increase. So there is a change because it is increased by, that means whatever we were having initially, it increased by 0.01. That means the change is 0.01 and change in height is 0.05. You have to find out the percentage change in the volume. So initially if you had V1 as volume and now it becomes V2, then the change, that means V2 minus V1, because you have to find out the percentage change. So initial volume in denominator into 100. This is what you have to find out, correct? That means we can write it as del V by V into 100, correct? Because del is change. So how we can calculate it? So because it is about volume, so you have to find out the volume of this whole figure, which is cylinder plus two hemisphere, which will form one sphere, right? So for cylinder you have formula for volume pi r square h, and for sphere it is 4 by 3 pi r cube, right? So now if you have to find out the change, what will be the change? Change means you have to do partial differentiation. So in V it will be delta V, because if you do the differentiation of x, it will be 1, right? But if you do differentiation of y with respect to x, you have to mark del y, correct? So del V here. Then you can take out pi r as common, or you can do it later on also. So what is there? If you see, there are two variables, right? Pi r square h, so you have to apply a product rule. Pi is here. For r square you have 2r in terms of differentiation, but what you are doing is with respect to r, plus you have kept h constant here. Now keep r square constant and partial differentiation of h will be delta h, correct? So this is your answer for this, pi 2r del r h plus r square del h. And for here what you have got is 4 by 3 pi differentiation of r cube will be 3r square, and because you are doing it with respect to r, so del r. 3 will be cancelled out with 3. So you can take thoroughly pi r common, right, from the whole. So you have taken pi r common. What is left? 2h del r, right? 2h del r. Now r has been taken out, so only r del h is left, and pi r has been taken out, so r del r, right? And 4 as well. Correct? This is your del v. Correct? Now, because you have to find out del v by v, so just divide it with this v. So if you divide it with v, del v by v, what is in denominator? V is what? You can take pi r common from here also. What is left? RH plus 4 by 3 pi r. Pi has been taken out, right? 4 by 3 pi r square, right? Because 1 r has been taken out, correct? So you can mention here RH plus 4 by 3 r square. Pi r cancel with this pi r. What is left? Just put down all the values. So del v by v, what you have got is h, which is 4, del r, which is 0.01, plus r, which is 1.5, del h, which is 0.05, plus 4r, which is 1.5, del r, which is 0.01, divided by RH, which is 1.5 into 4 plus 4 by 3 r square, which is 1.5 into 1.5. So when you solve these, you will get your answer as 0.215 by 9. Now, because you have to find out percentage error, right? So just multiply this with 100. So it will become 2, if you cancel this, right? 21.5 by 9%. That means you can say 2.388%, because all the digits are up to after 2 decimal places, so you can put it here 2.39%. So this is how you can solve this question, okay? Let's see another example of partial differentiation. Here what is given to you is, in estimating the cost of a pile of bricks measured as, so brick which is a cuboidal shape, you are given with length which is 2 meter, breadth 15 meter, and height 1.2 meter, right? And if you see, it is stretched 1% beyond the standard length. So all these dimensions, you have got a percentage error of 1%, correct? Because in error, that mason has increased it or stretched it by 1%. So this is also one. In height, you have got 1%. Okay, now what's there was for 450 bricks. So in 1 cubic meter, that mason counted that 450 bricks will be fitted there, okay? And the cost which he provided is 530 per thousand bricks. So you have to find out the approximate error, because the measurements had been taken wrong, so therefore there would be error, correct? So what's the error that we have to find out? So how we will do this? Again, if you have to find out the error in the cost, and cost is from 1000 bricks, correct? There are total 450 bricks, and dimension is in meter cube. That means you have to find out percentage change in volume, correct? Then only you will be able to get it. So volume is what? For cuboid, length into breadth into height. Now to get change, what you have to do, because it is again in multiplication, so you have to take log, right? So firstly, log v is equals to log L plus log B plus log h. Correct. Now you will do the differentiation, partial differentiation, which will be, this will log v. So 1 by v del v, because you are doing with respect to v, 1 by l del l, 1 by b del b, and for this 1 by h del h. Correct. Now, because you have to find out the percentage error in the cost, so just put down all the values. You have to simply multiply it with 100, right? If you do the multiplication, if I multiply it with 100, del v we don't know, but v we know. How? If you put value L, which is 2 into 15 into 1.2, so 15 to the 30, 12 to the 36, 36 meter cube, right? So this is 36, correct? And here you will get, this is 1. If you see, delta L by L into 100 is what? Is basically 1, right? So if you have to take this 100 is here, here is also 1, here is also 1, correct? Delta L by L into 100 is 1. Same here. So this has become delta V is equals to 3, 36 multiplication and 100 in division. So this is your answer for delta V, that is change. So actually what that mason did, he calculated 1 cubic meter as 450 bricks, but there was a wrong calculation of the change was 1.08. So for 1.08 meter cube, the bricks he calculated is this, right? So if you calculate it 1.08 into 450, this will come out as 486 bricks. Okay, now these are the bricks he calculated. Then the cost, we have to find out the change in cost, right? So for cost, 1 rupee 530 per thousand, right? But what we have got is 486. So 486 has 530 per 100 cost, right? So actually there will be a loss of this much amount to mason, to that contractor. So this is how you can apply significance of partial differentiation in the questions. I hope the concept is clear to you. And if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.